Okay, so guys, today I want to talk about the substitution technique for calculus for integration. So we'll take a look at that, some of the properties. So as you can see that, so for integrals of f of g of x, g prime of x, dx, so that equals the integrals of f of u, du, and then integrals of from a to b, f of g of x, g prime of x, dx, so that equals that integrals of f of u du from g of a to g of b. So this one is just like a general formulas. So the one is for definite integral, the other one is for the indefinite integral. So we'll take a look at that, some of the critical examples. Okay. And also there are certain properties that I want to talk about for the odd even functions. So for the integrals of symmetric functions, so we do have, if f is an even functions, that means integrals from negative a to a, f of x dx, is the same as 2 times the integral from 0 to a, f of x dx. So let's say that's an even function, so that means both sides are symmetrical. So instead of integrating one side, we just integrate both sides, so we integrate only one side. So let's say we do have trig functions like this. So instead of integrating that from negative a to a, so we just want to integrate it from 0 to a, and then we multiply by 2. And then if that's odd functions, so let's say we do have things like sine of x. So as you may notice, the area underneath the x-axis, so this part would be negative, and then the area over here, then that would be positive. And they're both considered symmetrical. So again, this part is negative a, over here is a. So once you combine them, so that means eventually it's going to be 0. So that means the integral from negative a to a, f of x dx, this one's going to be 0. So now, here's some of the substitution problems, So let's do one of those. Let's start with the trig functions. So let's say we do part B, integral cosine of theta to the third power, and then times sine theta, d theta. So anytime that you want to use substitution, that means u got to be the inner function. So u, we're using that cosine of theta. So u prime, we do have negative sine theta. So compared to the original integrand, so we do have cosine of theta. Sine of theta is also given, but we need the negative, so we need to make up the negative sign, the negative 1, and then negative outside. And then by substituting that u and u prime, so we do have negative integrals of u to the power of 3, and then u prime. And then basically just integrate it, so we got negative u to the power of 4 over 4, and then plus c. And then at the end, you want to unsubstitute, so it's negative cosine of theta to the 4th power over 4 plus c. So then that would be the integrals. And now let's try something else, so let's do d. So integrals e to the power of x, sine of e to the power of x, dx. So for u, we're using e to the power of x. That means u prime, it's considered e to the power of x, dx. So compare and contrast, so e to the power of x, dx, that's part of that, well, that's the whole thing for u prime. And then u, which is e to the power of x. So by substituting that e to the power of x, so we got sine of u, and then du. So integrals of sine of u, which is negative cosine of u. And then plus c. And then unsubstitute, so we do have negative cosine of e to the power of x plus c. Okay. So now let's look at some of the complicated problem for the U-Substitution. Okay, so we'll look at that one of the part of the problem. So let's say h. So let's do h right there. So for h, we do have integrals. Again, it's indefinite integral. So we got sine of natural log of x over x dx. So for u, we're using natural log of x because that's the inner function. And then u prime, so we get 1 over x dx. Again, compare and contrast, 1 over x dx, that's u prime. And then u, which is natural log of x, so we're going to substitute that in. So sine of u du, or we can say that u prime. So u prime and du is pretty much the same thing. Depends on which one that you like. So integrals of sine of u, so we got negative cosine of u again, plus c. And then unplug, so we got negative cosine of natural log of x plus c. So some of those, they're pretty obvious. So by the time they set up that u prime, so you can just integrate it directly. And now let's do j. So for j, we have rational expressions. But in terms of the rational expression, we do have sine of x on the top, and then 1 over cosine square of x down the bottom, dx. So you might be wondering, u would be 1 plus cosine square of x. But the thing is that if you try to set it up like 1 plus cosine square of x, then that's kind of difficult to integrate because that derivative of 1 plus cosine square of x. So this one does not exist on the top. So instead of using this whole thing as u, so we're using u as cosine of x. So u prime, which is negative sine x, and then dx. So again, u prime, so we have sine of x given already, dx that's also given, but the things that's missing, it's negative, negative 1. So make up negative 1 here, multiplied by negative 1 outside. So we got negative, and then it's going to be 1 over 1 plus u squared, and then u prime. And also for the u prime, you can put it on the top. And as you may notice, the integrals of 1 over the quantity of 1 plus u squared is considered arctangent. So this one's going to be considered inverse of tangent, or arctangent of u. Okay. And also, let's see. So negative arctangent, so we got negative arctangent of cosine of x. Let's see. For the final integral. Okay, so now let's look at something else. So this one is getting even more difficult. And the one that I would like to show you next, let's see, then that would be considered, okay, let's try n. So n is showing that x squared over square root of 1 minus x dx. So let's find out a way to integrate this. So one thing that we notice, the properties of integral, again, this one is the definite integral, so there's no boundary, indefinite, excuse me. So that means by the end, so we're going to add the constant c right there. So a lot of people probably thinking about u would be considered 1 minus x. Okay, so let's do it that way, because that looks like it's an inner function. And then u prime, it turns out to be negative 1 times dx. So we do have dx, we do have 1 minus x for u, but the thing is that x squared, how do you deal with that x squared? So here's the little tricky thing that you have to do. So for x, we need to isolate that x in terms by itself. So we need to solve for x in terms of u. So the way to solve for x, so we swap that x and u on, well, to both sides. So we got x equals 1 minus u. And that means x squared equals 1 minus u quantity squared. So right here on the top, we got 1 minus u quantity squared. And then down the bottom, we do have square root of u. And then the negative, so we just need to make up the negative 1 here, negative outside. So we do have u prime. So by the time they realize this one, so this one is just like the binomial expansions, and then the bottom part, it's a radical. So for this one, we just want to expand it. So integrals of 1 minus 2u plus u squared over u to the power 1/2, and then u prime. So anytime that you try to integrate it, it's better for you to integrate it term by term. So for the next step, I want to separate them so I can integrate it each term at a time. Okay? So this one, it's 1 over u to the power 1/2. In other words, that means u to the power negative 1/2. Minus, so 2, u to the power 1, and then u to the power 1/2. So it's the same base. We subtract the exponent. So it's u to the power of 1/2. And then for the next one, so it's u to the power 2 minus u, well, divided by u to the power 1/2. Again, quotient, so that means we need to subtract the exponent. So 2 minus 1/2, which is 1.5. So it's 3/2. And let's see what else that we have for the rest of this. Okay, so we got 1, 2, 3, it's supposed to be 3 terms, so let's see what went wrong here. Okay, so this one is u to the power negative 1/2 minus 2 u to the power 1/2. I don't know why I put a u right here, so this one just cancel it. Okay, so it's plus u to the power 3/2. After you separate them. And now, so just integrate it. So we got u to the power negative 1/2 plus 1, so we got 1/2 divided by 1/2 using the power rule. And then minus 2 times u to the power 1/2 plus 1, so we got 3/2 divided by 3/2. And then over here, u to the power 3/2 plus 1, so we got 5/2. And then divided by 5/2. And then at the end, plus constant c. So eventually that's going to be the final structure, but don't forget, you need to plug in that the original u. So u that we set up originally, that's 1 minus x. So unplug this, so we got 2. Okay, let's put it right here. So we got 2, and then times 1 minus x to the power of 1/2. And then minus 2 over 3/2, so we got 4 over 3. Again, u, 1 minus x to the power of 3/2. And then over here, well, divided by 5/2, that means you multiply by the reciprocal, so 2/5. And then u, 1 minus x to the power of 5/2. And then plus c. And here's the one for the final solution. So the next one I'm going to show you, it's about the definite integral. So the definite integral, you need to change the boundary. So anytime that you try to apply the U-substitutions for the definite integral, so you want to change the boundary. The upper limit and the lower limit for the integral. Okay, so now let's do some problem for the definite integral. So evaluate the definite integral. Let's start with the easy one first. So let's start with A. So that one is integral from 0 to 7, square root of 4 plus 3x. Okay, so let's find out what to do with that U-substitution. Okay, so from 0 to 7, integrals of 4 plus 3x dx. So u, obviously, it's an inner function, so it's 4 plus 3x. Differentiate it, so u prime, so we do have 3 dx. Okay, so we do have u, we do have dx, but 3 is missing, so we need to multiply by 3. And then outside, we need to multiply by 1/3. So we can even things out. Another thing that you might be considered doing is the boundary. So you have to change the boundary. Because right now, we're using u as the variable. So for x equals 0, so for u we do have 4 plus 3 times 0, and that'd be 4. And that's the new value for the lower bound. And then for b equals 7, so u equals 4 plus 3 times 7. So we do have 4 plus 21, so then that'll be 25. So now for the new integral, so we got 1/3 integrated from 4 to 25. Okay, so 3 dx, again, that's u prime. So we got that. And then square root of u. So square root of u, which is considered u to the power of 1/2. So you want to convert that from radical to the exponential form. It's easier to integrate it. So once we find out the simplest form, so now we can integrate it. So we got 1/3. So integrals of u to the power 1/2, which is u to the power of 3/2 over 3/2. And don't forget the boundary is from 4 to 25. Again, this one is called the definite integral, so that means it's going to show the exact value. So we got 1/3 times 2/3. And then we're going to use part 1 of FTC. So 25 to the power of 3/2, which is 5 to the power of 3, and that'll be 125. And then 4 to the power of 3/2, then that'll be considered 2 to the power of 3, which is 8. So 1/3 times 2/3, so we got 2 over 9. And then 125 minus 8, then that'll be 117. And then cross cancel, so 9 goes into 117, let's see. Then that would be considered 13. And then 2 times 13, 26. And that's what we got for integral. Again, this one is called a definite integral. So anytime that you try to use the U-substitution with the definite integral, you need to change the boundary, the lower bound, and the upper bound. So now let's do the one that's a little bit more complicated. Okay? So let's look at that d right there. Okay, so for d, we got integral from negative power 2 to power 2. It looks like this one's kind of like a symmetrical relationship. And then we do have x squared sine x, and then 1 plus x to the power 6 dx. Now the thing is that they try to use the U substitution, so it's very difficult to set things up. Because that denominator is like x to the power 6 with the binomial. And then the top part, it's not just x squared, but also that involved with sine of x. So it doesn't matter which way that you set that u for, and then u prime, it's very difficult to be defined. Okay? So instead of doing that, let's do some analysis. So back to the property that we talked about earlier. So if the function is considered odd, that means the integral from negative a to a with the odd functions, it's always considered 0. So now let's look at that, x squared over 1 plus x to the power 6. So all of this, they're all considered even. But back to the trig function, sine of x is always considered odd. So let's say you do have an even number, power, times the variable with the odd number power. So eventually, the whole function is going to be considered odd. So 2 is even, 3 is odd, same base, we combine exponents, so that's the odd functions. So that means the integrand is considered an odd function. So anytime that I try to integrate it from negative a to a with the odd functions, the results is always 0. So this one, nothing you need to do, just show me the analysis. So integrals from negative a to a with this whole integrand, so eventually it's going to be 0. Okay, so now let's do the one that which is integratable. So now let's do f. So for f right here, so we do have integral from e to the power 3 dx over x, and then square root of natural log of x. So u prime Well, I'll start with u first, so natural log of x. In u prime, we have 1 over x dx. So as you may notice, so 1 over x dx, they're all given. So which is u prime. And then u, it's also given. So the only thing that we have to change, the boundary. So for a equals e. So that means u equals natural log of e. So we got 1. And then for b equals e to the power 3. So equals natural log of e to the power 3. Then that'll be 3. So let's just reset the integral. So we got 1, 2, 3. So dx over x, which is u prime. So let's put that on the top. And then over denominator, so square root of u. Then that'll be u to the power of 1 half. And then just rewrite it. So we got 1, 2, 3, the boundary. And then u to the power of negative 1 half, u prime. So integrate it. So we got u to the power of 1 half divided by 1 half. So that means multiply by 2. And then it goes all the way from 1 to 3. And then using FTC part 1, so we do have 2 times 3 to the power 1 half minus 1 to the power 1 half. Well, the reason why that I took out 2 because 2, that's the greatest common factor. So 3 to the power 1 half, nothing we can do. Leave it with square root of 3. 1 to the power 1 half, that's 1. So eventually, it's either written as 2 times the quantity of root 3 minus 1, or 2 root 3 minus 2. Okay? So now let's see what else that we have for the rest of this. That's it. There's some other problem that you might want to try, so it's on the list right here. So try to use the property, or using all the strategy, the technique, things that you learn from calculus. So thank you for watching the video today.